In this video, I'll show you how to make a mash tun from a picnic cooler. If you're like me, your home brewery went together with parts that fit the immediate need in price and functionality. This 5-gallon picnic cooler has served me well as a mash tun, but being 5 gallons, it limits me to about 12 pounds of grain. I also can't do very big beers or 10-gallon batches. Because of that, I decided to use a larger Coleman picnic cooler that I got at Kmart, and I'll show you the technique I used to do that. There are several guides and theories on the subject, but the ones I followed satisfy these requirements. Number 1, the manifold needs to support both batch and fly sparging. This translates to very fast drainage for batch sparges and even fluid flow for fly sparges. Number 2, the manifold is sturdy and doesn't contribute any flavors. For this reason, I selected copper pipe. I decided to use a 52-quart cooler, a slotted copper manifold, and a brass ball valve. I'll show you each part in detail. The cooler is a rectangular 52-quart Coleman cooler I got at Kmart. Retails for around $40, and this sweet baby can be found in the sporting goods department. Shop smart. Shop Kmart. You got that? Here's an exploded view of how it'll be laid out. Starting from the outside, there's the 1/2 brass ball valve threaded, a brass washer, number 15 rubber O-ring, a 2-inch brass nipple, another O-ring and another brass washer, an adapter, and then the manifold itself will consist of 1/2-inch copper piping that'll be soldered together. The exception will be these end caps here. They won't be soldered, but they'll be clamped into place, and I'll show you a way to do that. The manifold itself, the straight parts here, will all have slits on the bottoms, the sides, and the tops. A couple options for cutting your pipe. You can use a pipe cutting tool here. Just screw it on, you turn your pipe, and it cuts it. When you're done, you can use this tool. I think it's a flaring tool, but you can use it to true up the ends of your pipe. You just turn it in like this, and it makes the opening nice and uniform. Here's what the manifold looks like with all the pieces cut and dry fit together. The next step is to solder. If you've never soldered before, here's a few basics. You're going to need some sandpaper, which is used to clean the outside of the pipe and the inside of the joint, some soldering paste or flux, which is applied with Q-tip. It has acid in it, and that helps clean the joints when it's heated. You need propane to supply the heat, and you need some solder, which will be used to join the pieces together once it's heated up. It's not critical that this be completely perfect soldering job because it's only meant to hold it together at the bottom of the mash tun. Okay, all the pieces have been sanded, flux has been applied, it's all back together ready for the soldering. I have these pieces of scrap copper underneath here just to lift it off the wood, so when I heat it, it'll have some space underneath for the flame to get to. So I'll begin soldering. When soldering, it's always best to heat the joint. That's usually the thickest part of the metal. You don't need a ton of solder, just enough to hold it into place. Here's a view of the manifold inside the cooler. I haven't cut any slits in it yet, and the caps aren't installed. But I'm just illustrating what it'll look like when it's done. Here's detail of the valve assembly. There's a 1/2-inch threaded brass ball valve, a brass washer, number 15 O-ring. The cooler wall will be in this space right here. Another number 15 O-ring, brass washer, and an adapter. The end of this adapter will tie in to the manifold inside the cooler. When you put these together, make sure you use Teflon tape on all the threads. Had to tighten it down quite a bit, but there's no leaks. I put water in it for about a half hour, and no leaks. Good news. The manifold's complete, so now it's time to start cutting some slits. When you do this, it's really important to remember, especially if you're doing fly sparging, to not cut these vertical pieces here and just stay with the horizontals. The reason for that is because if you do cut these along with the horizontals, you'll create a zone here of lower pressure. So when you do your sparging, it'll favor this area more for extraction and not so much in these longer pieces here. Also, when you cut them, you have a couple choices. You could use a reciprocating saw, a hack saw, a multi-tool. I prefer to use a Dremel tool with a metal cutting wheel on it, and it's just a matter of cutting some slits in this pipe. I'm going to do the bottom. This is upside down, and you can also do the tops and sides as well. It just has to be as uniform as possible. Here's a finished product. It has slits on both sides of the pipe, and you'll notice a late design change here. It's these street 90s on the corners, and that keeps it centered inside the mash tun. When I was done, I sanded the outside to remove a lot of the burrs. Also sanded the inside, and to do that I used this, which is a flute cleaner. Put a strip of sandpaper on the end, ran it through with my cordless drill, and removed a lot of the burrs from the inside. Flux still needed to be removed, so I used carburetor cleaner. Ran that through and rinsed it out really good, washed it with soap and water and all that. I also mentioned that I would show you how to secure the caps. To do that, you can use a channel lock like this. Just kind of squeeze in very gently to make it a little bit out of round. When you go and put the cap on, it'll stay on really well, really snug, and won't come off at all. So I'll show you what this looks like inside the mash tun now. Here's the final product installed in the cooler. You'll notice I joined the manifold with the outlet valve using this clear plastic tubing that I've used in other applications in my brewery. Also, the street 90s on the end help keep it centered. As I mentioned earlier, this kind of manifold design is good for fly sparging as well as batch sparging. For fly sparging, it leaves an even distribution across the bottom. So as you sparge, it will have even extraction across your grain bed. Also, for batch sparging, it has plenty of slits in it, so it allows for very fast drainage of your wort.